In this second visit to the math modules in AI, we're going to look at some of the further functions and operations which are offered as standard and how they can be useful to you in your patching. Okay, so today we're going to look at two main math modules. So in the math section, we've got formula, which we're going to add in, and we've also got vector math there as well. Deceptively, vector math can be used on non-vectors, whereas the formula editor can only be used on non-vectors, and there is a separate vector formula editor for vectors. I'm not sure if I was clear on the vector math. The vector math can take vectors and non-vectors. Okay, so I'm going to do these sums, and I want to show the calculation results on a little window. So I'm going to add a patch in. Now in the system patch, there is a text patch which we supply. Now we're going to need to convert our value into a string to put into the text patch. So in the text section, we have convert to string, like so. We'll just connect that one up. We'll add a couple of constants and we'll turn them into text so that we can enter our values into those boxes. And then we're going to connect those up to the ports on the module. And then let's just open the window, like so. Okay, great. So we can see the output there, and let's just give it a quick test. So we've got an addition there. So if I put 1, add 2, we should see 3, which we do. Okay, that's great. So now that we know that our module is up and running, let's have a look at some of the functions. So on the drop-down module, the drop-down menu on the module itself, there are quite a few functions in there, and a lot of these will be familiar from your days at school. Addition, subtraction, multiplication, division. There's some ones that are probably going to be new to you, things like modulus, things like does not equal, and being able to clamp maximum and minimum values and stuff like that. So let's dive in and have a look. So one of the ones I mentioned there was does not equal. So you'll be familiar with the old equal signs. So this is the reverse of that. Now some of the functions like addition and subtraction, the module will output the resulting value from that operation. But some operations are more like true-false statements. So when we use things like does not equal, instead of receiving the resulting value, we will either receive a 0 for a no or a 1 for a yes. So let's give that a try and let's see what happens. So at the moment we're saying 1 does not equal 2. And so it's giving us a 1 for that because that is correct. 1 does not equal 2. But if we change that so that it's 2 does not equal 2, we get 0 because that is a false statement. So this particular operation can be quite handy for checking incoming data streams and checking it against incoming values. And conversely, you can use the equal function in the same way. So if we were using the equal function here, in fact let's swap to the equal function, there we go, we get a 1 for that because 2 is in fact 2. And if we go to there, 1 is not 2, so we get a 0. Okay, so another really useful one is modulus. So what modulus does, it takes one number from the other number and gives us the remaining values. So what we're saying here, we're saying we've got an incoming value of 3 and we want to take away 2. And so when we take 2 from 3, obviously we get a 1. So if I put that first one down to 2, we'll get a 0 as our result because there is nothing remaining after I've taken the 2 from the 3. Now you'll notice that if I put this up to 4 and we look for the amount of 2's in the 4 and see how many remainders we get left over, we get none. So this module will actually keep adding as many of these second inputs, so in this case the 2, until it can't add any more, and then it will look at the remainder. So if we go to 7, for instance, it will give us a remainder of 1 because we can cleanly get rid of 6 of those units with our 2's, and it just leaves 1 left over. So that can be another quite handy tool. Lastly on this little module, let's look at the minimum and maximum clamps. So, minimum clamp. So when I use the minimum, the value coming in at the top is not allowed to exceed the value stated at the bottom. So if I just push that up a little bit, so we can see at the moment that we're actually receiving a 4, and that's because this 7 has exceeded the 4, and for as long as it exceeds this clamped value, it will stay at that value. So you can see as I'm increasing at the top, it's staying as 4 as an output. But then when I go below 4, we will actually see the true value. So anything below that clamped value, we're almost there. There we go. We see that value until we hit that clamp. And so conversely, if we check out the max function, so this is basically the same, and it's saying the value coming in on this second input, it will show this value as long as it is greater than this top value here. So as I go down to 3, and it's not going to let me go any lower than 3, as we would expect. Okay, so next, let's take a bit of a look at the formula editor. So the formula editor's got some really useful functions in there. I've mentioned before that it uses a library called MuParser. So if you Google MuParser, M-U-P-A-R-S-E-R, you'll get a complete list of the functions. I believe I showed them in the other maths tutorial as well. So let's just get set up. I'm going to just duplicate that a couple of times. Okay. So again, I'm going to take the output, convert that to the string, get that onto my window, and let's just plug in 3 constants. So you'll see the difference here is we've got our inputs, input A, input B, input C, input D, and we can actually refer to them here in statements. So just to give you a really quick idea, A plus B. So that, when I press enter and then I compile, I'm expecting that 1 plus 2 is going to give me a value of 3. And it does. Okay, cool. You can even take this slightly further. You can start to use brackets. Now, when you use a bracketed statement, anything within the brackets will be calculated before the parts outside of the brackets are applied. So, for instance, we can do, if we do that. So we're going to do A plus B times C. And I'll show you the 2 different ways when I take the brackets out in a moment. So that, for me, that's going to do 1 plus 2 is 3 times 3. That's going to give us 9. And it does. Now, if we take the brackets out of that, we get a different value. Yeah. So you can see that the brackets can change how your statement works. So now that we know that, let's have a look a little bit deeper at some of those functions. So some really useful ones. Let's go for to the power of. So you know when we say like 2 to the power of 2, so that would make 4. 2 to the power of 3, that would make 8, and so on. So we can actually do this function here. So it's A, and it's this little upwards arrow. This is, for me on my Mac Pro Retina laptop keyboard, it's Shift and the 6 key. So we're going to do A to the power of B. So that's 2 to the power of 2, and that gives us 4. And then, as I mentioned, if we change it to 3, it's going to give us 8, and so on. So the to the power is a really useful one. Sometimes you might need to get an average of values. So let's go for 4 and 8. So when we do an average statement, and there are a few like this, we put the function, then we enclose all of the parts within the brackets that we want to actually work with on that function. So for average, we put AVG, then we put our inputs. We put A, comma, B. So I'm saying that I want to see the average between 4 and 8, and I'm hoping that's going to give me a 6, which it does. So averaging makes total sense. Another really useful built-in function, especially if you're dealing with circular areas, is pi. And quite simply, you can type in pi, and that will give you the value of pi, rather than you having to know 3.141593 and so on. Another useful one, this kind of goes back to the average thing a little bit, into the power of thing, square root of. So with this one, we can do SQRT, square root, bracket, and then the value that we want the square root of. So what I'm going to do, so it's saying that the square root of 4 is 2, which is actually correct. Just to confirm this, I'm going to put in 9, and I'm hopefully going to see 3 as my value, which we do. Okay, so that's really nice and easy. Last trick for the day. Sometimes when I am working with incoming values, I have decimal places to the value, but I actually only want to use whole numbers. I don't want to use those decimals at all. So we have a function called round to the nearest integer, which is given the rather catchy name of rint, round to integer. So we can do rint a, like so. So at the moment, we're just going to see a 9 for that, because 9 is what we've got in there. But what you'll see, just make this box a little bit bigger, if I start to add little decimal places, you'll see this doesn't actually affect the number at all until we go past the halfway mark. Now this is an interesting point here. So you'll notice that when it gets to 0.5, that is technically closer to 10 than it is to 9. When it goes below that, it's going to hit 9. So sometimes I will put in a little offset. So I don't want it to hit 10 until it actually hits the value 10. So what I'm going to do, I know that it's an offset of half. So I'm actually going to do minus 0.5 in my formula there. So it's a minus 0.5, and then rounding that to the nearest integer. If you remember, inside the brackets is calculated first, and then the outside argument is applied. So now when we calculate, we should see 9, which we do, and all the way up to 10. See, 9.9 is still 9, and only when I go to 10 is it going to go to 10. The same, this will stick, and it won't hit 11 until we hit that 11 mark. Okay, so there's a few extra useful tips there. As with any math system, the learning never ends. It goes on and on and on. So it's worth brushing up on your algebra, worth brushing up on your trigonometry. We'll do a whole other video on using trig in AI, because that's really, really useful for calculating real-time positions of components based on things like motor systems.